This lesson has to do with solving right triangle problems using trig. There's two words that I really want you to understand. One of them is the angle of elevation. And here is the example of the angle of elevation. We have the line of sight, and then we also have this line that is parallel to the ground. So this is called the angle of elevation. Now, the other example is a line of sight. You're looking forward. Now, this right here is when you're looking down. And so this right here is called the angle of depression. An angle of elevation is an angle through which the eye moves up from the horizontal to look at something above. And the angle of depression is the angle through which the eye moves down from the horizontal to look at something below. So one is above, one is below. For two observers at different elevations looking at each other, the angle of elevation from one equals the angle of depression for the other. The concepts are illustrated in those two pictures that I just showed you. The angle of depression of a buoy, from the top of the bay of the lighthouse is 130 feet above the surface of the water is 30 degrees. Find the different distance x from the base of the lighthouse to the buoy. So we're going to solve this algebraically. You notice that we have here, this is 30 degrees. And you do remember from your geometry course that if you have two lines that are parallel and they're intersected by a transversal, these two angles are going to be congruent. I did explain to you earlier in this topic the mnemonic statement so, ka, toa. And so we're looking for the distance of the buoy to the lighthouse, which is right here. That's called x, which is the adjacent to the angle and the opposite. So what you're going to have to use to find that distance is called tangent of theta is equal to opposite over adjacent. And so what we're going to write is we're going to write tangent of 30 degrees is equal to the opposite measurement, which is 130 degrees. 130 feet over the adjacent measurement, which is x. So we're going to solve this algebraically. So we're going to go ahead and come up with two fractions. We're going to cross multiply. So we have x times the tangent of 30 is equal to 130 feet. And then we're going to divide by the tangent of 30. So let's go ahead and let's use our calculator. So make sure that you are in degrees. So I'm going to go to mode. Right now it's in radians because if we use degrees, we use radians, we're going to get it incorrect. So it's going to be 130 divided by the tangent of 30. So the distance of the buoy to the lighthouse is 225.2 feet. So here's example 2. It says from the top of the 100-foot tall hall, a man observes a car moving toward the building. If the angle of depression of the car changes from 22 degrees to 46 degrees during the period of observation, how far does the car travel? So we're going to work with this little triangle here, the smaller triangle, because we know that the angle of elevation is 46 degrees, and we're going to work on finding this distance. We have the opposite, which is the height of the height of the tower or the hall, and we're going to find the distance. So it's opposite and adjacent. Once again, we're going to use tangent. Remember to the mnemonic statement, so, ka, toa. So we're going to use tangent of 46 degrees is equal to the opposite, which is 100. Opposite is 100 feet over the adjacent. In this case, it's D. I'm going to go ahead and cross multiply. So we have D times the tangent of 46 degrees is equal to 100 feet. Then we divide by the tangent of 46 degrees, divide by the tangent of 46 degrees. So the distance will be 100 feet divided by the tangent of 46 degrees. So we're going to go ahead and write 100 divided by the tangent of 46 degrees. And so that distance will be 90. I'm going to round it off to the nearest foot. So I'm going to say it's 97. So this is 97 feet. Now we're going to have to focus our attention on the bigger triangle. Like the problem said, the line of sight did change. So we know that's 97 feet. So the distance from the car and the hall now, because the line of sight changed, will be x plus the 97 feet. And you're still using tangent, so it's going to be tangent of 22 degrees equals opposite, which is still 100. But now it's going to be x plus 97. Okay. So we're going to go ahead and cross multiply. We're going to make this into a fraction. So we have x plus 97 feet times the tangent of 22 is equal to 100 feet. And since we have tangent of 22, we're going to go ahead and apply the distributive property. So we have x times the tangent of 22 degrees plus 97 times the tangent of 22 degrees is equal to 100. So I'm going to rewrite this so you can see it. X times the tangent of 22 degrees plus 97 times the tangent of 22 degrees is equal to 100. And you're just going to go through the process as if you were solving this equation. You were solving a linear equation, so you have negative 97 tangent of 22 degrees minus 97 tangent of 22 degrees. So you have x times the tangent of 22 degrees is equal to 100 minus 97 tangent of 22 degrees. And I'm going to go ahead and move it up just a tad. The last step will be to divide by the tangent of 22 degrees. But you're dividing the whole thing by the tangent of 22 degrees. So I'm going to go ahead and use parentheses. I have 100 minus 97 times the tangent of 22 degrees. And then I'm going to go ahead and make sure that you have parentheses around the entire expression. And then divide by the tangent of 22 degrees. and you get 150, I'm going to say 151 feet. So the entire distance from this point to this point will be the sum of 151 feet plus the 97. And you get 248. You get 248 feet. So that distance, when the car moves away, that total distance is going to be, so the car has traveled 248 feet. That means it's the distance from here to here, the entire distance. So we started off by writing down tangent of 22 degrees is equal to 100, which is opposite over adjacent. We have x plus 97 feet. So we have x plus 97 feet. That's going to be in parentheses times the tangent of 22 degrees. I did the distributive property, so you have x times the tangent of 22 degrees plus 97 times the tangent of 22 degrees. And that's still equal to 100 feet. And I rewrote the equation here so you can see what I'm doing. I'm subtracting 97 times the tangent of 22 degrees. I'm subtracting 97 times the tangent of 22 degrees. So this entire expression, which is 100 minus 97 tangent of 22 degrees, is divided by tangent of 22 degrees, which gives you 151 feet. So it's actually from here to here. The total distance traveled, you have to add 97, so you get 248 feet. A large helium-filled penguin is at the beginning of the parade route, awaiting the state-of-the-art to start the parade. Two cables attached to the underside of the penguin make angles of 48 degrees and 40 degrees with the ground and are in the same plane as a perpendicular line from the penguin to the ground. So, just so you know, the penguin or the balloon penguin is right here. So the balloon penguin is right there. Okay, so we have two cords that are holding on to the penguin, and at this point, this is the height of the penguin as perpendicular to the ground. When I say perpendicular, that means it's making a right triangle. So you notice that we have two right triangles that are formed. One of them says that the ratio of the height to the distance from the people that are standing at the end of the first chord is x in measurement. In other words, it's at x feet away. So the tangent of 48 is going to be the opposite, which in this case it's h, over the adjacent. Now, the next chord or the next cable makes a second right triangle, but it's 10 feet further from the first cable. So we have the distance from here to here is going to be 10 or x plus 10, and the ratio for tangent of 40 is going to be opposite, which is h, over x plus 10. So now what we're going to do is we're going to solve this algebraically. You're probably thinking, how can we solve it if we have two unknowns? So what we're going to do is we're going to solve for h. Since h, they have both h in common. So we know that h is equal to x times the tangent of 48 degrees. And I'm not going to solve, or I'm not going to evaluate tangent of 48 degrees because I want to work with tangent 40 degrees. I want to work with that expression there. The next one is going to be h equals x plus 10 times the tangent of 40 degrees. So you know that both expressions equal to h. So I want you to think about, what do you think we should do? So I'm going to go ahead and pause the video. So hopefully you did pause the video. You notice that they both are equal to h. So what you're going to write is x times the tangent of 48 degrees is equal to x plus 10 times the tangent of 40. Okay. So think about what could be the next step. If you look at the left side, you have x times the tangent of 48 degrees is equal to, and if you look at the right side, what you want to do is you want to do the distributive property. So you have tangent of 40 times x and tangent of 40 times 10. So you have x times the tangent of 40 degrees plus 10 times the tangent of 40 degrees. Now, that 10 tangent of 40 degrees is fine where it's at. You notice that we have x on both sides. Think about what we have to do. So go ahead and make sure you pause the video right now. So let me rewrite this. So we have x tangent of 48 degrees is equal to x tangent of 40 degrees plus 10 tangent of 40 degrees. So I do want the x values to be on the same side. So what I'm going to do is I'm going to subtract x tangent of 40 degrees minus x tangent of 40 degrees. And you're probably saying, well, how are we going to subtract those two? You're actually going to write it as a difference expression. In other words, you're going to write it as a statement. So what you're going to have, you're going to have x tangent of 48 degrees minus x tangent of 40 degrees is equal to, and this is gone, that's 0, 10 tangent of 40 degrees. Now, if you look at the left-hand side, you notice that there is an x in common. So what we're going to do is we're going to factor the x. So what are you left with? You're left with tangent of 48 degrees minus tangent of 40 degrees is equal to 10 tangent of 40 degrees. And yes, you have to divide. So you have tangent of 48 degrees minus tangent of 40 degrees. So you have tangent of 48 degrees minus the tangent of 40 degrees. And that's going to be the value of x. So the value of x comes out approximately 30.9045973. Of course, I didn't round off. So we need to solve the height. So to solve the height, we just have to substitute into one of the equations. I'm going to go ahead and substitute to the second one, the first one, I'm sorry. So you have h is equal to x times the tangent of 48. So you already know what x is. So h is going to be approximately, the height is approximately 34 feet. You are expected to write down the steps for these 3 problems. I know that the video is 20 minutes long. Go ahead and make sure you understand how to work these 3 and then submit into It's Learning. Thank you.